Welcome. Today we'll talk about voice for real work without hype. It should take about 55 minutes. Plus, I will try to have 10-15 minutes for Q&A. Feel free to drop questions in the chat and I will answer as many as I can. I'll also demo QR inventory with voice capability so you can see something real. We'll start with discussing 3 very different things people call voice-enabled apps. Second, we'll touch on the recovery problem, why every serious voice system lives or dies on what happens after the recognizer mishears. Third, we'll see 5 concrete workflows where voice is really useful. Then I'll pop up the hood and show you a bit of what drives QR inventory. I would be remiss if I didn't honestly talk about limits, where voice doesn't help, and what the system does about it. If you came expecting AI marketing that ends up with a discount coupon, you'll be disappointed. If you came to figure out whether voice is real productivity for your operation, I'll do my best to help you. So, let's start. There are 3 different things people call voice, and they are not interchangeable. One is voice dictation. You press a button, say the words, and the phone's speech recognizer types them into a field. The system has no idea what you said. It just transcribes. Most products marketed as voice-enabled inventory are this type. They are useful for taking notes and absolutely useless for complex workflows. Number 2 knows voice commands. In other words, knows several fixed phrases that match fixed actions. Scan, opens the scanner. Submit, submits the form. It works reliably if the user has memorized all the commands. It breaks at the moment the user says something slightly different. If you say, open the scanner, instead of scan, it will be confused. Good part, it's steady in noisy rooms. Bad part, it's brittle on phrasing. In most apps I saw, manual widgets to tap and do the same thing are available. This is good. The third type, specially trained AI. It involves natural language understanding. AI language model interprets what was said and figures out what you meant by it. Info on GX98234 or set quantity to 10 will be parsed as two intents with their separate parameters. This is where the meaningful productivity gains are found. AI matters more now, since on-device language models became practical for phones. Before that, this was a server problem. Now, it isn't. Same 3 categories, side by side. Let's look into the details. Dictation. You say 2753. The field reads 2753. Commands. You say scan. The scanner opens. And if you say open scanner, the scanner opens just as well. Voice AI. You say info on GEP 98234 or item 2. Set quantity to 10, and the system understands what needs to be done. Does voice learn phrasing? Except AI, no. Every phrase is fixed. Voice AI, yes. The model handles paraphrasing. Does it work for free-form fields? Dictation works. Commands, no. Voice AI, yes, it works. Error recovery, dictation and commands. You need to repeat phrase you said. Voice AI uses phonetic and fuzzy math fallback plus confirmation prompts. We'll see this in the demo later. The privacy row is the important one. Dictation and commands depend on where the speech recognizer runs. Voice AI depends on where the speech recognizer and the language model both run. Both have to be local for the audio and transcript to stay on the device and not to be sent somewhere else. We'll come back to this in a couple minutes. The left column is where voice consistently wins. The right column is where it doesn't, or, at least, where it needs work. Voice helps most when hands aren't available for tapping. Your gloves are on, or your hands are dirty. You are up on a ladder. Walking inspections where you're moving and recording at the same time, or you got the item in one hand and the phone in another. Multi-field updates. Saying quantity, 10. Condition, good. Notes, received without damage, is genuinely faster than tapping through 3 fields. Voice helps less in very loud environments. When you are standing next to a compressor, honking traffic, working power saw. Above about 75 decibels of background, recognition accuracy drops. It also helps less for long alphanumeric IDs. Privacy-sensitive contexts, customer's living room, hospital corridor, anywhere speaking the inventory aloud is awkward, and single-tap workflows where tapping is already fast. For your business, two things matter most: ease of use and recovery. Look at the diagram. This is the distinction that matters for regulated industries and matters as a category of risk for everyone else. Everything inside the phone box happens locally. The microphone captures audio. The phone's speech recognizer turns that audio into text. The device language model takes the text and extracts the intent and the parameters, what action you wanted, against which item, with what quantity, at what location. Nothing on this side gets uploaded. The audio doesn't leave the phone. The transcript doesn't leave the phone. The model's intermediate work doesn't leave the phone. What goes to the server is the structured query: item ID, quantity, location, intent. It is the same payload a manually tapped transaction sends. Voice changes how the worker generates it, not what gets sent. I want to be real clear about two things. The voice processing is fully on-device. The database is in the cloud, because that's what enables 10 people across 5 locations to see the same stock at the same time. Transactions and lookups still need a connection. Voice understanding does not. Ask any vendor, what gets uploaded when and where to? Get it in writing. One slide on the principle that runs underneath the whole product category. Then we go deeper. Scan to identify the item. QR or barcode are the fastest, most reliable path from your item to system record. Voice to add context, quantity, condition, location, notes. There are fields where scanning does not work: button and touch point at the moment of commit. All three inputs need to be available on every screen, with no input ranked above the other. Voice-only products fail when the worker can't or won't speak. Manual-only products fail when hands are not free. After a lot of testing, we came to the hybrid. You pick what you need at the moment. Our conviction is that strongest products keep all three available on every screen. This is the principle we will keep coming back to. ASR stands for Application Speech Recognition. And here is the real-life problem you might want to consider. Voice success is not the same as transcription accuracy. Even excellent speech recognizers mishear something from time to time. In a warehouse with the gates opening and forklift passing by, that rate gets worse. There's no way around it. Speech recognition we have today is excellent, but it still misfires sometimes. The strategy should solve the question, what the system does after the recognizer mishears. That's a different problem, with different code and a different design budget. A lot of products marketed as voice-enabled have invested in the recognizer and not in what happens next. The result looks great in a demo and falls apart in a warehouse or on job site. In the rest of this section, we'll see 4 common failure modes and see why a less accurate system with strong recovery beats a more accurate system without it. We should also see several recovery patterns during the demo. There are 4 distinct failure modes, each with its own recovery pattern. First is mishear. The recognizer hears the wrong word. The classic case is 8 versus the letter A. They sound identical out loud, and ASR can't always hear what is what from acoustics alone. Same for 0 versus O, especially when you say O inside a number. Second is what we call missed slot. The user said the whole sentence, 2 pumps from warehouse 5. And the system caught the item and the quantity but didn't catch the location. The intent is right, the data is incomplete. Third, ambiguous reference. The user said, the blue one. Which blue one? The system has the words, but the words don't resolve to a unique target. Fourth, drift. The user changes their mind mid-sentence, which is quite normal for people. Where do we have pumps? Forget it. Generators. The system locks in the first intent, processes against it. Each of these has its own recovery. We'll see recovery patterns in the demo. In this slide, I will try to reframe how you think about voice quality. Imagine two voice systems. The first is 98% accurate on transcription. The second is 92% accurate. Which one is better? Most people would pick the first. It's wrong. The 98% system in this example has no recovery layer. When it mishears, it acts on what it didn't hear right. The worker might not notice until the wrong item shows up on the truck a week later. The error rate is 2%. The cost per error might be enormous. Backtrack, recount, refile. The 92% system catches its own uncertainty. When a lookup fails or the confidence score is low, it asks, "Did you mean that?" The worker corrects potential problem in one phrase. The error rate is 8%. The cost per error is few extra spoken words. When you extrapolate the two systems across 1,000 transactions, the second wins by a wide margin, not because it's more accurate, because it knows when it's wrong. Folks who pitch accuracy are pitching the wrong number. You need recovery. Now, let's talk about these 5 recovery patterns. Each of them addresses one of the failure modes we just discussed. I will try to show each one during the demo. Phonetic fallback. When an ID lookup fails and the ID contains a digit that sounds like a letter, 8 versus A, 0 versus O, the system retries with a substitution. Most mishear failures resolve here before the user sees anything. Fuzzy slot matching. When the spoken slot value doesn't exactly match anything on file, math helps us catch single character errors. High confidence autocorrects. Medium confidence asks the user. Confirmation prompt works for medium confidence matches and ambiguous inputs. The system asks, "Did you mean this or that?" before acting. Number 4. Long input override. If the user starts saying something complex during a yes or no confirmation, the system cancels the confirmation and treats the new utterance as a fresh command. You're never stuck in a confirmation loop. The last one is auto process pause, that is, 2 seconds of silence before acting. It gives the worker room to add to a sentence without the system jumping ahead. All of these recovery cases determine whether voice is usable in real environments. 4 workflows where voice is really productive. Let me start with the canonical case, the one many of you will recognize from your operation. Receiving. The worker pulls up to the loading dock. Trailer's open. Phone is in one hand, dolly is in the other. The system needs to know it's a receiving transaction, the destination is the main warehouse, and there are about 30 items coming off this truck. Voice opens the transaction. Do receiving transaction. Done. The transaction type selector resolves. The system understood I want a receiving. From location next, main warehouse. It could be simply main warehouse, but could also be row 2, bin 6. It might be as detailed as you want. Now the phone goes into a pocket or a small dock and the worker frees both hands. Each item gets scanned with the rear camera at a steady angle. Quantities, voiced item by item. No menu navigation. No typing on a phone with dirty gloves. What's worth noticing, every step has a manual button. The mic icon stays on screen. If you decide voice isn't working here and now, the tap path is right there. That's why you want a hybrid interface. Second workflow. Voice used to work with your company's specific custom fields. An item comes back damaged. Maybe it's a piece of returnable equipment, maybe a tool, maybe a part that the customer didn't end up needing. It goes back into receiving with a condition update, a quantity update, and a note describing the damage. Slow path, open the item, hit update, open the quantity field, tap, type, save. Open the condition field, scroll the drop-down, select. Open the notes field, tap, type the description, save. 3 field updates, 3 round trips through the user interface. Maybe 30 seconds of focused tapping and typing. Fast path, tap update, tap the mic, say it. Set quantity to 10. Set condition to good. Set notes to received with cosmetic damage on the housing. 3 custom fields, 1 utterance, about 8 to 10 seconds. The damage photo follows. Voice triggers the camera. Capture, attach, done. The damage record is complete. The next worker who looks at this item sees the full story. Quantity, condition, notes, photo. Not just a quantity adjustment that someone has to follow up on. Custom fields take voice. Drop-downs take voice. Freeform notes take voice. And it works. Third workflow, stock lookup in the field. Tech is on a service call. In a crawl space, flashlight in one hand, phone in the other. He needs to know if the warehouse has a 1-inch PVC elbow before he tells the customer he needs a return trip. Slow path, open the inventory app, navigate to search, type the keywords, filter by location, read the results. Possible, but inconvenient with one hand and a flashlight. Fast path, do we have any 1-inch PVC in warehouse 1? The system understands it as a stock query, extracts the keyword, extracts the location, runs the lookup against the shared cloud database, returns the result on screen. Fourth workflow, voice as an accessibility feature. It can make a difference between your guy using the system or not. Workers with hand injuries. Workers operating heavy equipment that requires 2 hands at all times. Workers on ladders or scaffolding where tapping the phone invites the risk of dropping it. In these situations, voice isn't faster. It makes work possible. The tap path may be the better fit for somebody else doing the same task tomorrow. Today, it isn't an option. And the voice path is the difference between being able to do the inventory work or not. That expands who can do the work, including people who would otherwise be limited to a narrower set of tasks. One slide on the speech recognition layer. QR inventory uses your phones, Androids, and iPhones' built-in speech recognizers in offline mode. Recognition runs entirely on the phone. We don't use ours or a third-party voice service. There's no upload step. We do not claim that voice will improve over time as we collect more data from your phone because there is no collection and we never see your data. Why it matters? If the speech-to-text layer runs on someone else's servers, you have no control of what happens to your audio. That's an architectural choice. Some products make it. We made the opposite one. State that plainly when your security team asks where voice processing happens. One slide on the language model. We use AI language model we fine-tune for inventory management. Its size on disk is about 800 megabytes. Inference runs right there on your mobile phone. We configure it for greedy decoding, which means that the output is deterministic. If you give it same input, you will receive same output 100% of the time. That's important for inventory. Voice command consistency matters more than creative phrasing. Model is downloaded from the App Store at the same time as the rest of the mobile app. It is on the phone the moment the install completes, not downloaded on first launch. Until very recently, this wasn't practical on phones. The combination of better mobile hardware, smaller models, and available software tools made it possible. The on-device LLM is the difference between real voice AI and voice commands. The most important slide for your security team. Here's what stays on the phone and what leaves. What stays? The microphone audio. The transcript from the speech recognizer. The data sent to the language model. The output from the language model. Your intent and details that app figured out. The matching math computations, all of it. Only one thing leaves the phone. The structured inventory query to the inventory database. It is the same payload a manually tapped transaction generates. Voice doesn't change what gets sent, it changes how you generated it. Voice understanding runs on the phone with zero network dependency. The inventory database is in the cloud because that's what enables multi-user, multi-location, real-time data, same architecture as any modern team inventory system. Ask any vendor what gets uploaded, when, and where to. Get it in writing. Compare. I want to spend a minute on a feature we removed. We shipped text-to-speech audio in an earlier release. The phone would speak inventory results, status, confirmations. Something like item ABC 123, quantity 10 in main warehouse. Audio feedback is useful for hands-busy work where looking at the screen isn't always convenient. We found two problems with that. It interfered with the microphone. Mic picked up the app response as new speech. The recognizer would start a new session in response to the phone speaking to itself. Misfires followed. We measured the error rate. We tried echo cancellation, source separation, half-duplex modes. None of it brought the recognition reliability back to where it needed to be, so we made a call, replaced TTS audio with a visual notification pop-up. Same status information, conveyed silently, no microphone interference. The second problem, listening to what the phone says isn't always the best option, as we found out. Another, though minor problem, voice generation and listening to voice is slower than reading. Finally, why this is on a slide, every vendor will tell you about features they shipped. Vendors who tell you what they took out and why, I think, are more trustworthy. We finally got to the demo. Here is a plan of what we're about to do. Workflow 1. Voice-guided full transaction setup. Start transfer by voice. Voice the from location. Voice the to location, then hand off to scanning. Workflow 2. Multi-field update on a returned item. We'll update several custom fields with voice and then take a photo and submit transaction.
And the third workflow. I'll perform a transaction switching back and forth between voice and a traditional tap-the-screen interface.
I'm switching to the phone screen now.
Okay, let's start. Do transaction transfer. Select from location B27. Select to location Boise warehouse. Next, button scan QR code. Line item 2, quantity 1. Line item 1, button properties. Field, job number. Job 1. Notes. Good condition. Photo. Submit. Button submit. Here we are, prepared and submitted a transaction using voice. It included custom fields and taking a photo, all in under a minute and a half. Now we do workflow 2. Do transaction return. Select to location B27. Next, set customer to Joe's Construction. Set reason to wrong size. Next, button scan. Button properties. Set condition to ideal. Button photo. Submit. Submit transaction. You can see the app gets GPS location and sends photo we took along with the rest of data. Another transaction is in the books and it took us under a minute. Button home. In this app screen video, we'll see that the voice is not required to use the app. You can switch back and forth between voice and regular screen interface and use what is more convenient for you at the moment. We'll start with voice. Do transaction receive. Switching to regular interface. Back to voice. Next. Voice off again. Done. Submit transaction. What you just saw in the QR inventory workflows. First, voice-guided transaction setup. Second, multi-field custom field update with a voice-triggered photo. Third, ability for a user to use voice and regular touchscreen interface interchangeably. There are 3 things I want to name before we move on. First, every voice step happened on the phone. Audio didn't leave. Transcripts didn't leave. The on-device language models' intermediate work didn't leave. The only thing that went to the server was the structured query, same as any manual transaction. Second, every screen kept the tap equivalent visible. The mic icon was one option. The buttons, the drop-downs, the form fields, the scan trigger were always next to it. You pick what you need at the moment. Third, recovery. If you saw a confirmation prompt or a phonetic retry, that's the recovery layer doing its job. Recovery is the feature, not raw transcription accuracy. Voice processing is offline. Inventory visibility is shared. The goal is not a cooler demo, it's less problems in real-life situations. Now, the most honest slide in my deck, when you do not need QR inventory. Don't take me wrong, we want your business, but if you have very few line items, or you don't carry much inventory, and you don't have many tools and equipment that you want to track, you probably can live without. On the other hand, if you carry inventory of supplies and want to know what you have and where, if you want to know where is that power generator or that tissue sample, if you send something to a job site and then want to account returns, want to know what and how much you used for this or that project or customer, QR inventory would be of tremendous help. Using it, you will know exactly what is where. Be prepared for compliance audits and will never be caught flat-footed by a simple question, how many widgets we got? I hope the time you spent on this webinar pays back. Thank you for the time, and let's start with your questions. I see we got some.